Hi to everyone. This is Dr. Srinivasan from MCA department, Madanapalle Institute of Technology and Science. Today I am going to deliver Introduction to Software Engineering. So why I want to do this topic means you see that's global in IT, but everyone we want to know about what is software engineering. So software engineering, it is nothing but it is a field of study. So that we have to see in details. The flow of presentation today: introduction, definition, software development lifecycle, principles of software engineering, key roles in software engineering, challenges in software engineering, characteristics of software, and emerging trends in software engineering. Then the references we have to discuss in this manual. Let's we go first slide. Introduction. And initially I said the software engineering is nothing but it is a one field of study. So that field is called an IT. That information technology we have to discussed in detail, that is in software engineering. Today I have to present only for introduction of software engineering. Okay. In that term, the software engineering is composed of two words. One is software, another one is engineering. The software you see, that is simply it is called software is a product, is it? That engineering is somewhat it's called in principles. So if you want to develop the product, you have to implement the principles. So that principles in order. So once you implement the principle, then only we got a very good quality of the software. So that is the thing we have to discuss here. That is, a software is more than just a program code. A program in executable code which serves some computational purpose. That's why I said it is a product. If I want to develop the product, we need some protocol. We need some principles. That principle is called an engineering principles. You see, every industry they follow their own principles. That principles you have to follow, then you can obtain the economical softwares, then you can obtain the economical product. That product is unreliable. So that is a thing, it's a that word software engineering will be described. The second one is we go for definition. There are some educators and publishers, they are given some definitions. For example, in my own definition, the establishment and use of sound engineering principles in order to obtain the economical software that is reliable and work efficiency on real machine. You see, from this definition, you can understand simply what is software engineering. The first one is the establishment. We can develop and use of sound engineering principle. That principle it is called engineering process. Once you implemented in engineering principles in order, then only we can obtain the economical software. That is a valuable one. Okay, that software you can implement in real mission. So that is the thing, that software engineering definition. And there's someone that IEEE defines what is software engineering: the application of systematic, disciplined, cognitive approach to the development, operation, and maintenance of the software. Okay. So we can alternatively view it as a systematic collection of the past experience. Once you can implement your process, that process we can get more exposure in previous one, that is an existing. Already you have to implement it. If you find any problem or if you find any rectification on your process, that experience you can apply for the next level, I mean next cycle. So once you can that exposure, that experience you can implement it in the next upcoming development, automatically your product will become a quality. So is it, the experience is arranged in the form of methodologies and guidelines. So that is, the small program can be written without using software engineering principles. Yes, exactly. Without software engineering process, we are not succeed. We are not able to succeed the very good quality product in IT industries. But one want to develop the large software product, then software engineering principles are absolutely necessary to achieve the good quality software cost efficiency. So that is the thing I have to reminder one more time. If you go for very large projects, if I want to develop the very large project, definitely we need a software engineering process. Then only we can what is that, we got the good quality software cost and efficiently. That's all the thing we have to got it when you have to use the software engineering principles. Without using software engineering principles, it would be difficult to develop the large programs. Exactly. If you are developing a small project, I mean, a small project means, for example, I'm going to develop the what is that invoice management system. I'm going to develop the employee management system. These all the thing we don't want any process. We don't want any principles for I have to apply for this. What is it? Criterias, and we no need to time because see, this project it will take only 1 month or in few weeks they are taking for completing the project. Okay, but once you go for industrial project, once you go for large project, definitely we need a software engineering help. Okay, so that's why the software engineering helps to reduce this programming complexity. So okay, so the next important thing is software development lifecycle. And before the slide, I hope you all understand what is software engineering. Okay. The software engineering, the term software, it is called the product, and engineering, it's called the process. Once if I want to develop the product, you can implement the process. Okay. So that process we have to discuss it in there. Then the second, we go for software development lifecycle. Okay, this is very important, this cycle. Okay, this is some of the several stages we want to cross it. Each and every stages is very important in your industrial process. Okay, the first cycle is requirement analysis. You see, if I want to develop the product, we need some requirements. That requirement you are going to analyze. Whether you, before you are going to start your project, you make ensure all the requirement it is satisfied or not. If it is satisfied, then only you are going to involving the next step. Then only you can go for another process. Then you're going to start your project. Okay. If it is not satisfied your requirement, again you go back. Okay, you can go back, you can analyze this until the requirement will satisfied on your requirement. Okay, that is called requirement analysis, understanding user needs and definition the software objectives. Okay, then design. Once the requirements we got it, so all the requirements we need, for example, I'm going to develop the hospital management system. So if you are going to develop the hospital management system, what is the basic requirement? I need the data about that hospital. Okay, for example, I'm going to collect the patient data, then I'm going to collect the doctor's data, then I'm going to collect the infrastructure data, and other what are the softwares we need for you are going to develop that application, then how many programmers we required for developing that application. These all the things are basically the requirements. If once you satisfied these all the requirement, then I'm going to involving the second stage, that is called the design. Okay, then you're going to start your design process of your application. Design is creating the architectural and the detailed design of the software. Based on the requirement, you start the design structure. Then implementation. After completing the design, then I'm going to start to implement my writing and actual coding. Based on the requirement only, I can start my coding. For example, initially I'm going to create the login page. In login page, what you have to create? For login page, I'm going to create a user ID and password. Is it? Okay. If I want to create a coding means once you give the user ID and password, then I'm going to click the submit button. Once you click the submit button, automatically my login page, I get the authentication, then I'm going to log in my hospital management application. So this thing, this is called the implementation you're going to do in your implementation stage. After completing the implementation, what is the next stage? It is one of the valuable stage, I think so. It is a testing period. You are going to test the application. Once you complete the testing, then only your application will get the quality. It is not only for IT, but whenever you go for in other industries also, after product delivery, they are going to test the product. Why they are going to test the product? Once you test the product, then only the product will deployed as a quality product into the market. The same thing will happen in IT also. In IT also, once you are developing the application, then you are going to testing your process. Okay. So you are going to test your application. That after testing the application, then only you have to ensure your product is quality or not. Okay. After that, you see that next stage, after testing is completed, my product will deployment. Okay, where is user environment, there you have to deploy your application. After deploying, you are the another one of the stage is called maintenance. Okay, so after deploying the product to the user environment, You are going to make a agreement for 1 year or for 2 years. I'm going to take the maintenance of that application. That maintenance will take care about by the IT companies. Okay, so updating and refining the software and post deployment. So this is the thing. It's very important for software development life cycle. Okay, then we go for some principles of software engineering. This is some of the principles are there in software engineering. Let's see, modularity, it is one of the principle, abstraction and reusability and scalability, testing and debugging. These all the principles is very important in software engineering. Let me see one by one. Modularity. Modularity, it is nothing but modularity referred to breaking a software system into the smaller manageable components or modules. So this is the thing is modularity. I will give one example. You take an example of web application. Okay, in web application may have a separate module. Is it? One module is authentication module, another module is a payment processing module, then data storage module. So this is the process is called modularity. It is one of the principle. Each every software it should be a modularity. Then abstract. Then abstraction involve hiding complex details and exposing only the necessary parts of the system. Okay. In object-oriented programming, they can say object-oriented programming. It is an let's I take one example. A car class. A car is a class. Okay, so that might expose the methods like start engine method. So in class method, I have to use one of the method. That method name is called start engine method, but hide internal details how the engine is operated. So this is the process is called abstraction. Okay, then another principle is called reusability. Reusability referred to designing software components in the way that they can be used across different projects or part of the systems. Okay, so let's take the example. A library or application provide the authentication function can be reused across the multiple application instead of writing the code from the scratch. So these all the thing it's referred to the reusability principle. And one more principle is called scalability. This is scalability is the ability of the system to handle increasing the workload efficiency without performance degradation. Okay, so that thing is building the system that can handle increased workload. Okay, so for example, you see the cloud-based application is there. No, the cloud-based application that can scale the horizontally by adding the more services when user traffic increases. According to the user traffic, the services will be increases. So this is the thing is called scalability. Then last principle, testing and debugging. This principle focus on verifying that software function correctly and identifying the errors, that's a bugs, before deployment. Okay. For example, unit test. There is a one kind of test available. There are some types of test is there. In that type, they have a unit test. It is one of the type. It is a major type of the text. The unit test check individual components while integrating the test, ensure the different part of the system work together as expected. So these all the principles in software engineering. So then we'll move for the next slide. What are the key roles in software engineering? Because it is also very important aspect in the basic level. What are the key roles they playing in software engineering? Okay. So for example, software developer and software architect, then quality assurance engineer and project manager. So these all the roles they're playing in software engineering. Let me see what is software developer. It is a developer. The word has got the meaning. Developer, who's a developer, they're going to develop the application. So the developer is responsible for writing, testing, and maintaining the code that build the software applications. For example, a front-end developers build the user interface while the back-end developers managing the database interface. There is a two developers are there in IT industries. One is called the front-end, another one is a back-end tool developer. The front-end tool developer, for example, I am going to write the program using Java. So that is you are going to make the design of your application. They are going to write the coding for integrating the application. These all the thing is called the role played by the front end developer. Then backend developer, he is a role of playing the backend tool development. For example, he's going to connect the database into the wherever. For example, I am going to use the Oracle, so that person is going to connect the Oracle. Then you're going to manage the database interactions. Okay. Then a software architect. The software architect, he is the software architect design the overall structure and framework of the software system. For example, a software architect might decide whether use the microservices or architecture for the projects. Then another one is quality assurance engineer. So he is already know that he is ensure that software meet the quality standard before deployment. Then project manager oversees software development project and ensuring that ensuring they meet deadlines and requirements. There is a project manager. He is one of the topmost position in that team. Okay, he is handling more than one or two projects. They are going to involving one or two projects simultaneously. They have a role of consulting to others for how to develop that concept and how to develop that project logical concept that they are given the role in software manager. They have playing this role. Then one other important thing is some of the challenges in software engineering. These are the challenges you have to face in software engineering: rapid technological changes, complex requirements, and quality assurance and resource constraints. So, based rapid technology changes, keeping up with evolving the technologies. For example, nowadays there are based on the rapid development, there are upcoming tools are every day. They are going to introducing the new applications in that software process. Technology evolves rapidly with the new programming languages, frameworks, and tools emerging frequently. For example, you see a company using an outdated technology stack may need to transition to the modern framework like React or Angular to stay the competitive. So these all the thing is very challenging. For example, I'm already using one application with C languages. I want to what is that transfer to the new technology. Now this enable technology will come, which is very comfortable for shifting from one technology to another technology. Then complex requirements. Software projects often have diverse and changing the requirement based on user needs and business goals. Based on the user requirement, that will be complicities will be changes. Then quality assurance, that already so that balance speed with the throughout the testing. So for example, once if you want to get the quality, that whole process we have to get it. Then resource constraints, limited budget, the tight schedule and workforce shortages can impact software development. These all the things we have to maintain in the resource constraints. So these four challenges is how to face in your software engineering role. Some of the characteristics in software engineering, that characteristics are reliability. The software should be a reliability, then it should be a scalability, then maintainability, then cost effectiveness. So these all the characteristics you have to meet in your software engineering. Then we see that another thing is called emerging trends in software engineering. So there are some emerging trends or in current IT industry. That one is artificial intelligence, cloud computing, agile and DevOps, and cyber security, and low code and no code platform. These all the emerging technologies for in current IT industry. Let me see one by one. Already you are all are very familiar for artificial intelligence, AI in development. That is called automatic code generation and testing. For example, you say nowadays everyone we have to use for chat GPT. So these all one way of for what is that automated code generation applications. And then we go for cloud computing. The cloud computing enable developers to build and test and deploy the software on remote services. There is a emerging one rather than relying on local infrastructures. For example, you see AWS cloud, then Google cloud, then Microsoft Azure cloud. So these all there are so many service providers are available in that current trend. Then Agile and DevOps. Nowadays, it is playing the main role in all the software industries and Agile and methodology. It is one kind of methodology. This methodology, interactive development and quick adoptions to changes requirements. DevOps combine the development and IT operation to streamline the development and improve the software quality. Then already know the cyber security is everywhere. Wherever you go, the cyber security is playing the main role. The cyber threats, that's called increase the software engineering, focus on building the secured application to protect the user data. So that low code and no code platforms, these platforms enable non-programmers to develop the application using visual interfaces and drag and drop tools. Okay, so many tools nowadays are available. This with help of the tool that each and software developers can achieve the product in very within stipulated time. So this thing is called low code and no code platforms. Example, you see our systems and Mendix and Microsoft Power Apps. So these all the example tools for low code and no code platforms. So this is the emerging in software engineering. Let's see today my the introduction of software engineering summary. For example, what we have to conclude for this today session. Because today I'm going to take only for introduction only. For first we see this what is the software engineering. So what is the definition of that? So what is the role of software engineering? What is the characteristics? Then what is the principles of software engineering? What is the role of software engineering? These all the things we have to conclude today's section. For example, I have to follow some reference. I didn't. I have to follow this only one reference for because of the basic level. So I have to follow the one only one reference. You feel heavy. If you have any suggestion, please kindly post this suggestion in this link. Thank you very much.